If it says figure out if it's parallel, perpendicular, or neither, they both start out the exact same way. They start with the cosine of an angle. Let's call it alpha. Is going to equal the dot product on top. So that's 2 comma 3. Maybe a 2. There we go, 2 comma 3. With the dot product, we have 1 comma 5, which would be over the square roots because we're finding the magnitudes. So that would be 2 squared plus 3 squared times the square root of 1 squared plus 5 squared, because that's how you find your magnitudes. You just square your a, b, and take the square root. Well, that's going to equal 2 times 1 is 2, plus 3 times 5 is 15, bless you, all over the square root of 3, 38, if you plug all that in your calculator, or you plug in, let's just break it apart first. So at first you'd have 9 plus 4, which is 13, times the square root of 26. Well, to figure out what alpha is, you have to take the cosine inverse of both sides. I would plug all of this in my calculator, so that'd be 17 divided by, and then if I was plugging this in my calculator, I'd put parentheses. So that's if I was plugging in my calculator, I'd make sure to put parentheses on over my denominator, which comes out to about 22.4 degrees. Any questions on any of those steps? This is the same thing you'll do every single time I ask for angles between vectors. And it'll be the exact same thing as if I ask you, are these parallel, perpendicular, or neither? Just be careful here, because sometimes when you see two vectors, you immediately find the resultant. Did I even need the resultant here? No. I just need a dot product and magnitudes on the bottom. All right, what questions did we have from the homework? Yeah, Charlie.
Okay, so for 51, like, for the answer, on the bottom, it was 5 square root 2, and then you had, like, cosine of something else, and I put 45, and I wanted to know why it's not 45.
I use 45 degrees.
For the bottom one?
Are we talking about number 51? Am I looking at the wrong thing? So 51 is the z sub 1 times z sub 2 and z sub 1 divided by z sub 2?
Yeah.
Am I looking at the right problem?
Yeah.
Okay.
Yeah.
So 51 says do z sub 1 and make sure you're in trig form, right?
Mm-hmm.
So the first thing you need to do is find trig form of both of them. So that's basically the bulk of the work, is finding the trig form. So let's look real quick here. So I did in fact use 45 degrees, so I use the point 44 and the point -5, -5.
I'm asking why it's 225 there.
Oh, why it's 225 here.
Oh,
So
yeah.
you do get out the 45 degrees,
Okay.
but look where it is.
Okay. I was just...
It's a little past 180, so you would have to add the 45 degrees to it. That's why we always plot it, because 45 degrees wouldn't make sense for this. So if we look at that angle, this is my theta. Theta is definitely bigger than 180, so you have to add 180. So that's why it's not 45.
Yeah.
Make sense though?
Yeah.
So you did the right work, because 45 should have came out. Other questions from the homework? Yeah, Mike.
So for 47 and 49, that would turn into subtraction.
It would turn into subtraction?
Like, division would become like subtraction. Between the...
Oh, yeah. So 47, you should have had 4 divided by 2 up front, right?
Yeah.
So you'd get 2. And then you'd have the cosine of pi over 3 minus pi over 6.
Yeah.
Correct?
Yeah.
Yep. Division tells you to subtract your thetas or whatever angles you're talking about. Did you need to see the answer, or are you?
Well, I just needed like a clarification that was the reason why.
Yep, yep. It's because it's division. That's why I use this subtraction. And with multiplication, you add them. So for instance, 43 is addition, so you'd have that 10 degrees plus that 20 degrees. That's why you came up with the 30 degrees as your theta.
Yeah, I just wanted to make sure that that was.
Nope, you got it. You got it, sir. Other questions? Yeah?
63 and 65.
63 and 65.
I just didn't know what we were supposed to do.
You were just overthinking it. All it asks you to do is find the conjugate. It was just asking you to find the conjugate. So if you turn to page 164 on the bottom, it says that the complex conjugate of a trig is you just have to switch your theta if it's positive. So let's go through that real quick. So 67, I think 69 is a little more interesting. So no, 65. So the complex conjugate is just going to be 2 square root of 3 times cosine of, instead of negative 20 degrees, it's going to be a positive 20 degrees, plus I times sine of, once again, it'll be a positive 20 degrees. So it's just changing the signs of your theta.
Okay. That makes sense.
Other questions? Questions going once? Twice? 3 times? 4 times? 5 times? Okay, so let's get into today's lesson. Today's lesson is on the polar coordinate plane. Surprisingly enough, we're not learning all that much new material. We'll learn kind of how to plot again, but we already know how to plot things. It's just we're plotting it in a different way. Kind of like with complex numbers. Rather than having an x and y value, we had a real component and an imaginary component, but it was still just like plotting like a normal x, y value. Same thing here. It says that in rectangular coordinate system, we need 2 bits of information to plot a point. We need the horizontal distance, which is our x, and we need a vertical distance, which is our y. The same thing with polar coordinates. I need 2 bits of information. However, with the polar coordinates, rather than having an x and y value, we're going to have a distance and an angle for that distance. So we have a distance and an angle become my new x and y values. So if we look down here and we see this r, this length r, well, that r is the same thing we've been talking about forever. It's our magnitude. It is our absolute value. In this case, we actually go back and we call it r. Let's use black. So that r is really just our distance. And distance can be calculated the same way, and we'll see on the next page. It's the same thing as, remember our distance, magnitude, all that stuff is going to equal square root of a squared plus b squared, or x squared plus y squared. So this distance is the exact same distance we've been talking about since vectors. The other thing we have is this theta. That theta is just our angle. That's just the angle we are rotating that one point around. And then rather than an x-axis, we just have one axis, and we call it our polar axis. So we have a distance. We already know about that. We already know how to find angles. Really, the only new word we learned here is polar axis. The other thing we're going to learn is, so at point 0, 0, on everything we've been talking about is our origin. However, with a polar coordinate system, we call that point right smack dab in the middle the pole. So our pole is, in fact, just our origin. All right, let's learn how to plot these. Let's learn how to plot them. I find the easiest way to plot a polar point is to find my distance first and then rotate that distance either by hand or by actually drawing it out. So let's look at the first one. The first one says it's 2, and the angle we have to draw it at is 5 pi over 6. So what I'm talking about finding that distance is just go on your polar axis and go out 2 units. So I just went on my polar axis, kind of 1, 2 units. All right, it's not my final. This is actually 2, 0 because I haven't rotated it at all. Now you're going to take that point that the distance is 2, and you're going to rotate, kind of like you're rotating that vector around until it gets to 5 pi over 6, which would be right here. And how I do that in my notes, I won't do this every single time, especially in homework because our graphs will get cluttered. But this is all I'm doing. I'm just rotating it until I get to 5 pi over 6. So this is, in fact, 5 pi over 6. That's it, though. That's how you plot the 2 points. Our next one is negative 3 pi. And why I want to start off with my distance first is this one's going to look a little different. The first thing I'm going to do is I'm going to go over negative 3 units. So I'll go over negative 3 units. That's 1, negative 2, negative 3 units. And now I'm going to rotate it pi units. Well, pi units is the same thing as 180. So it's going to end up here. That is my negative 3 pi. It's not going to happen a lot in this section because we're kind of just lightly talking about it. But realize that all the angles I'm giving you right now are positive angles. Positive angles are always going to go counterclockwise, just like when we're reading a unit circle, anything we've been talking about. Our positive angles always go counterclockwise. If it was negative, though, say this was negative 5 pi over 6, you'd have to go in the negative direction, which would be clockwise, so it ended up over here. So be careful about that. So plot your point. Right, if this is 2, we start at 2, and then rotate it whichever direction they tell you to rotate it. Another thing you can do, and we're going to do it on this one, is we can, let's not do it. Let's just go ahead and plot the next 2. Go ahead and plot those next 2. I'll plot them along with you, but try them on your own. Points that I did. So another way you can plot it, if they're both positive, is I know this is 3 pi over 4, so I can just go to 3 pi over 4 and count out 2 units. So if you know your angle and how far out you need to go, generally I just do this if it's positive, because if it was negative 2, you'd have to go in the opposite direction, but that gets more difficult to kind of picture. So sometimes if they're both positive, it's just easier just to find your angle and count out 2, 3, 4 units. But be careful when it becomes negatives because it messes stuff up. All right, you should have said negative 1, 450. Well, you realize 450 is too many rotations. That's way past 360, so you probably did 450 minus 360 to come up with 90 degrees for it. Okay, continuing on. Convert polar to rectangular form. Don't forget that rectangular form is just our x, y. Rectangular is what we normally talk about. It's our x, y. So I need to convert 210 degrees to have an x value and a y value. So let's start that off. So I'm going to need a x value, and I'm going to need a y value, and I need to be able to calculate that. This turns out it's the exact same thing as we did with vectors. And it's going to be the exact same thing we did with complex numbers. Because if we look to the left, if we look to our left, in polar, I have my distance and my degree, but that creates a y value and an x value we can calculate. If I gave you that triangle, you'd say, well, cosine of theta equals adjacent over hypotenuse. Well, it turns out that x just equals r times cosine of theta. First time we've seen that. And if I use sine, that's going to equal well, sine theta. I shouldn't just have sine equals. I should have sine theta is going to equal y over r. Once again, y is just going to equal r times sine theta. But we've done that a billion times. We've used those formulas a billion times to find our a, our b, and our x's and y's. We're just doing it one more time. So my x value is going to be my r, which is my 6, times cosine of 210 degrees, because 6 is my r value, 210 is my theta. And y is going to be 6 times sine of 210 degrees. Well, it turns out that is actually on our unit circle. 210 degrees is on our unit circle. And on our unit circle, cosine of 210 degrees is going to be 6 times negative square root of 3 over 2. And sine of 210 is actually negative 1/2. So I'll have 6 times a negative 1/2. Well, my x value is going to be negative 3 square root of 3. And my y value is just going to be negative 3. Now it does want rectangular coordinates. I have both the components there, but you should, if you want your full points, rewrite it as negative 3 square root of 3, comma, negative 3. That is my answer. That's the rectangular form. All right, the next thing just says convert rectangular to polar. So we're converting rectangular to polar degrees. To convert to polar degrees, I need a distance and I need a theta. I'm just going to hold on for a second, make sure everyone gets stuff written down. Okay, so I'm going to need an r value and I'm going to need a theta because polar coordinates are r, comma, theta. Well, r is just our distance, and distance equals the square root of x squared plus y squared. So that's always good. Maybe we'll make that our first step. Our second step is to find theta. Well, theta is just our directional angle. So we're going to use tan inverse, just like we've done a billion times. So let's go ahead and convert this one. I have negative 3 comma 6. So to find my r value, I'm just going to say r equals the square root of negative 3 squared plus 6 squared. 3 squared is 9, 6 squared is 36, so this is the square root of 45. What perfect square goes into 45, though?
9 and 5.
Thank you. And Teresa, thank you for raising your hand. It is going to be 9 goes into it, so we can break it apart into 9 times 5, which will come out to 3 square root of 5. So that's my r value. Let's go ahead and find our theta. Whenever I'm trying to find theta, we plot the point first to make sure what answer I get is whether I have to add it to 180, 360, or anything like that. So we're going to have negative 3, 6, which would be maybe about there. Where the height is my y value, which would be 6. My base is negative 3. So we're going to jump straight to alpha equals the tan inverse of my y value, 6, over my x value, negative 3, which comes out to about, I don't have it open to that page, anywhere near that page. I got negative 63.4. Does that match? Cool. So either Marley and I are correct or we're both wrong. Oh no! Charlie said we're both wrong. All right, negative 63.4 tells me either it's going to be 180 minus 63.4 or it's going to be 360 minus 63.4. Can someone raise their hand and tell me which one we're going to do, Marley? We're going to do the 180 minus my alpha in that case. Jack, is that what you got? Is that what you got? Yeah, good. So theta is going to equal 180 minus 63.4 degrees, which is going to equal 120, 116.6 degrees. Cool. Am I 100% done? Did I put it in the actual form that I wanted to? No, I didn't. I need to finish it off by going, well, that's 3 square root of 5, comma 116.6 degrees. In other words, you put your r in there, you put your theta in there, and you are good to go. Questions, comments, concerns? I want to bring one thing up in this section. That homework that's due today is the last thing that will be on this test. This will not be on Friday's test. I'm going to retract that statement. This problem could be on the test, but it'd be extra credit. All right, so anything we cover today or tomorrow can be on the test as extra credit. However, it can be on the final as a regular question. So if you know everything prior to today, you are good for the test, and we'll have a review Wednesday and Thursday on that. I'm also going to hopefully get you your review for your final to you by Wednesday as well, because some people like getting that early so they can start it and look at it and do that stuff. So hopefully I'll have that by Wednesday. It all depends if they can install the program or not on my computer. But Friday, this will not be on the test, and if it is, it'll be extra credit. Same thing as tomorrow's stuff. Also, make sure to bring your calculators tomorrow, because I might do some stuff where we graph stuff in our calculator in polar coordinates, because your calculator has a polar mode, and you can actually graph polar equations. They're pretty cool. You can create like cool spirals and heart shapes and stuff. Yeah.